Hello team. In this video, we're going to talk about site reliability engineering, which is a practice of systems management within Google that is very similar to DevOps. So Google engineers wrote a book about how they handle management of systems inside Google. So it's free to read online. SRE team members at Google are software developers, and Google has a 50% cap on operations tasks. When an engineer is managing systems in Google, he can spend only 50% of his time on manual work and actually managing the systems directly. The other 50% of the time must be spent on development. And what development do they do? Well, they build automation solutions or automatic systems. And the distinction between automation and automatic is that the automatic system can run and repair themselves. Like it can auto roll out updates, and if something goes wrong, it can roll back and keep working all the time. So SREs have this focus on building new solutions so that the management of the infrastructure is automated. So how does Google achieve this 50% time on development work? For example, if there are issues and software is not working, how do the SRE team members devote 50% of their time to writing automation systems? So in those cases, when the operational load goes above 50%, this operational load is redirected to development teams. Say the team that builds Gmail will have to help the operations team deal with the issues that are popping up, and assuming that this is Gmail creating the new issues. So they redirect effort to the development teams. And this forces both the SRE team and the development team to work together, similar to what we have in DevOps. And the operational team can help the developers make their application more robust and better integrated with the infrastructure so that it doesn't have as many bugs, thus reducing the operational load, bringing it below 50%, and allowing the SRE team to continue developing automation solutions. Google tries to have 1 or 2 incidents per 8-12-hour shift. 1 or 2 incidents per shift is a low enough number that the engineers will have time to dig into the problem, really understand what's going on, and write a post-mortem. And these post-mortems, we've discussed one of them before, allows everyone to learn from the failure and design solutions so that it doesn't repeat in the future. And also, having few incidents per shift avoids pager fatigue. And pager is because the on-call person might have to respond to an issue that happens, say, 2 a.m. in the morning. It can be a little bit unpleasant. So if you don't have a lot of issues, don't get overwhelmed, and then you avoid this pager fatigue, which is, this dread of being on call and having to deal with issues that pop up all the time. Another approach in Google is that of assigning error budgets to applications to allow them to change more frequently. So most services aim for less than 100% availability. This is because achieving 100% availability requires a lot of effort. So if you can operate with 99.99% availability, then that's much easier. And the difference between the two, this 0.01%, might be very small, so that users might not even perceive the difference. So you might spend a lot of effort achieving 100%, but for the users, it might not impact them at all. For example, we can just retry the request, and then we're going to get service the next time we try it. So it's not a big deal. So Google defines error budgets for applications, and as long as teams are within the error budget, they are free to deploy changes. This allows applications to evolve quickly. And when an application is experiencing many failures and goes below the error budget, then the developers have to stop pushing new changes and work on improving the robustness and the availability of their application. And what happens when there's a failure? When responding to failures, humans add latency. So Google tries to automate emergency response as much as possible. So progressive rollouts and automated rollbacks is one of the things they use to automate dealing with issues. And whenever there's an automated rollback, for example, then engineers can look at what went wrong and fix the problem and then try deploying again. But the fix was automated. And maybe humans didn't even need to get involved to solve that issue when it occurred. Google also writes playbooks, which is a series of steps that engineers can take to solve a given issue. So when human intervention is needed, these playbooks might help them solve the issue faster.